Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, sum root to leaf numbers. So basically we have a binary tree that has only 0 and 9 numbers. And we have the concept of root to leaf path, where basically we start from the root and go all the way to one of the leaf nodes. And then we construct a number out of that path. So for example, if the path is 1, 2, 3, we are going to create number 123. For example, here one of the paths is from 4 to 9 to 5, so that's 495. This side 491, so that's 491. And then this side is 40, so we add 40. And the goal of the problem is, once we do all of these for all the leaf nodes, we want to return the sum of all of them. And so, for example, for this one, these are the numbers from the leaf nodes. We sum them up and we return the value. Okay, so pretty straightforward. Now, when you want to traverse a binary tree, leaf all the way to the leaf each time, that's just an application of DFS. So that's exactly what we want to do. So what we can do is just do a DFS, straightforward DFS. Now we will need to figure out what we'll need to return, right? What we'll need to bubble up. And the answer is, when we get, for example, let's take this example here. We get to this one and the number is 495, right? Then we just return that up to the parent. And this one returns it up to the parent. And this one gets 491, bubbles it up to the parent, and then bubbles it up to the parent. Now this one receives 495 and 491. And then here, since it's 40, bubble it up to the parent, we get 40. And so this parent, the root 4, gets the sum of these two. Sorry, actually, let me just clarify a little bit more. So when we get to 495 here, it returns it to the parent. This one gets 491, returns it up to the parent as well. And now what this parent does, takes the sum of these two, right? And so it takes the sum of these two, bubbles it up to this one. Here we get 40, and gives it back to its parent. Now we have these two, the sum of these two, that this one returned to the parent, plus 40. And so that's what we get here. Okay, so that's the core idea of what we'll try to do. And so how do we do that? Well, we need first to pass to our DFS, let's call it just DFS. We need to pass the node. And remember, each node, so while we are traversing here, for example, how does this leaf nodes knows that it needs to have 495? How does it know that? Well, as we go along the path, we need to pass the numbers. So for example, here, we pass 4. Down here, we pass 49. And then when we get here, we add up 5 to it. We have 495. Okay? So that's what we'll pass in the parameter here. And now we know that we need to call it on the left child, and we need to call it on the right child, just as a structure. Now what should we return? Well, we know that if we don't have anything left, we just return 0, right? But if we need to check if the node is a leaf. We need to check if the node is a leaf. We may not need this, but we'll see. So we need to check if the node is a leaf. How do we do that? We need to make sure that it doesn't have a left child and doesn't have a right child. Now, if it has neither, we just return the number we have so far. But we need to add the value of the node itself. Remember, when we get here, we have 49. And so we need to add 5 to it. How do we add 5 to 49? So that we want to add up 5 so that we get 495. Remember, this is concatenating to get a number. Well, one way to do it is just to pass a string 49, right? And then add up 5, string 5, so that we get string 495, and then we convert that to a number. But this is not really ideal, concatenating string and then converting back to int. So what we can do is actually just use int. So how do we convert this one to that? Well, we need to multiply 449 by 10. So that gives us 490. And then we add 5, and that gives us 495. Okay? And this is basically just every time you want to add a digit, you can multiply what you have already and then add up the digit. And so that's exactly what we'll do here. So the new so far value is going to be just the previous one multiplied by 10 plus the actual value of this node. And that will keep it as an integer. Now here we want to pass so far again after updating it with the node value. Now this will give us the left side result and the right side result. So in this specific, for example, case for node 9, it will give it 495 and it will give it 491. So what should 9 do? 9 needs to concatenate them and then pass the result back to its own parent 4. And so that's exactly what we are going to do. So left plus right. Okay. Now you could of course do this with just like a self variable and just add it up when you reach the leaf node, but this is more clean to just return it with each node bubbling up the result to the parent. Okay, so that's pretty much what we need here. We just need to call to launch our GFS. Okay, so if we run this, looks like there is a small issue. Let's see where. Okay, sorry, we need both to not be present so that it's a leaf, right? So run this, if you submit, it gets accepted. Okay. Now in terms of time complexity, this is basically DFS, so it goes through all the nodes until it reaches the leaf for each. And so it's O(n) time because we just go through all the nodes. We do use space here because of the recursion for the stack, but at any point in time, we will keep in the stack only the as much as is in the path of a leaf. So it's going to be at most the height of the tree. So in terms of space, it's going to be O of height and then O of n time. Yeah, so that's pretty much it for this problem. Pretty straightforward. Thanks for watching and see you on the next one. Bye.